this form. I'm going to use the filter here, data tab. Prior to analyzing the ANOVA and T test, you need to use the options here, and then where is the add-ins, okay? And then, okay. The options and the add-ins, okay. And then Excel add-ins here. If you check out the Excel add-ins here, and then go analysis toolbox here, okay. And then you want to click the tab of data here, data tab. And then you can see the data analysis button here, right? We're going to use this tab throughout this course. Okay. Anyway, prior to analyzing data, you're going to rearrange data format here by using filter, right? The first, you can select your data set in the Excel sheet and then click the filter button. Okay? Automatically, the filter button gives you the tools to rearrange the data here. Okay? This one is the last column is a dwelling unit, and the column D, the number of cars. Okay? As you can see in the screen, the number 1, 2, 3, all groups are checked here. Okay? Select all. Deselect, select all, and then you want to select what you want. You want to select what you want to see. Okay? If you want to see only one, okay, here, here, and okay. Here. This is the household that possesses only one car. Okay? So this one can be copied like this. This one is target variable, number of trips. Number of trips from the households of the only single cars. Okay? Get the copy and then move to the second sheet and then here and paste. Okay? The same as this one. Okay, and then second one, you're gonna deselect the number 1, and then cars. Okay, this is cars. Instead of 1 at this time, you're gonna select the 2. Okay, right? And then target variable trips will be copied. And move to the second sheet, and then paste. The same as here, okay? And also the same procedure will be applied for the household of car 3, right? Okay. The dwelling unit, we're going to use the same method, the same technology here. Number 1, okay? And you're going to select households with dwelling unit 2, like this. Okay? Understand? Very simple. Cars. You will select. And then dwelling. When you use dwelling unit field, the remaining fields are selected all, right? So if you select the number 1 cars, and then also dwelling unit is number 1, okay? Why is that? This is the cars, number 2. And here is the number 1. Only 1, 2, 3, 4, 5, 6, 7 households. They have the 2 cars, and their dwelling unit is number 1. Okay? So you can selectively choose the data like this. You understand? Okay. So I'm gonna select. I'm gonna resume the data. The first one. Okay. This is the whole data, and then filter can be killed. Right? The data that returns to the original form here. Okay. The next step is to use the ANOVA table. The next step is to make ANOVA table based on the cross variable here. We're going to click the data analysis tab, and then we're going to choose what? Choose ANOVA. Where is ANOVA? Okay, here, ANOVA. There are three types of ANOVA. Okay? ANOVA single factor, we have the single factor, right? And then two factor with replication, and then two factor without replication. We have only single factor, right? Okay. Okay. And then input range. You select like this. This is the data. The labels in first row, right? Okay. You want to check this box. And output range, you can choose the range of output here, like this. And then okay. Okay. This is the ANOVA tables. What is F value here? Okay. And then P value is very small. Okay. Very small. Which means you can reject null hypothesis. Okay. Without hesitation. Right? Okay. Another ANOVA table for the dwelling unit is very simple by using the same procedure here, the single factor. You're going to change the data range here, right, like this. Okay? Okay. And we're going to choose another location to save the new result here. Okay?
Mm-hmm.
What is that value?
52.
Then also very small p value, right? You can reject H0. The rejecting H0 means there are difference between the groups. Okay? Among groups there is a difference. You have a large F value and a small P value. P value and F value are intertwined with each other, right? If P value, F value, if F value increases, P value decreases. They are intertwined, interrelated. Also, okay, and then now it's time to move on to the t-test. Okay, the t-test also conducted based on the data analysis step. Okay, you can find the t-test. Where is t-test? Here, t-test. So there are three types of t-test. The first t-test paired two samples for mean. And then two samples assuming equal variance. Two samples assuming unequal variance. Which one is our choice? Which one is our choice?
Equivalence?
The second one.
Yes.
So what is a pair test? Our data set is unpaired, right? The unpaired, they are unpaired. The household are nothing to do with each other, right? There are 8 households in group 1 and 15 households in group 2. Okay, there are no pairing system here.
Not couple.
Yeah. If you when you conduct a survey about the time taken to watching TV for women and men, right? In this case, the independently choosing the 50 men and independently choosing the 50 women, they are nothing to do with each other. Two samples are independent, okay, right? But how about the paired sample?
the 50 couples are chosen. 50 couples, the husband and wives. Husbands and wives, the chosen at the same time. In this case, the 50 sample are paired, right? You understand? So our sample corresponds to the second one, the equal variance. What is the other name? The another name of the equal variance? Pooled variance, right? You remember? Do you remember the pooled variance? Here. What is the pooled variance? Oh, sorry. So, do you remember that? Pooled variance. Pooled variance is the weighted average of each variances. S1 squared is the sample variance for the first group. S2 squared is the sample variance for the second group. And they are averaged with weights, the number of the examples here. N1 represents the number of examples in group 1. N2 is the number of examples in the sample size of this group 2. N1 minus 1 and N2 minus 1 is the degree of freedom derived from the theoretical mathematics. Okay? And you don't have to worry about that. Okay? And then they are weight. And then this is sum. The weighted average, the pooled average. Right? The pooled variance is computed based on the weighted average of sample variance for each group, each sample. Like this. Okay. Now it is assumed that we have the equal variances, pooled variances. It is assumed that we have the pooled variances, so we're going to choose this one. Okay, understand? I'm going to choose this one. Okay. And the variable range. The first variable, this means the first sample, right? First sample is this one. Okay. And second sample.
Label.
Sorry. The first sample will be chosen like this. To secure, to make sure that the resultant t value must be positive, should be positive. Okay. No problem. The sequence, if you change the sequence, the sign of the t statistics changes. Okay. No problem. The t-test is conducted based on the absolute value, right? T-test, t distribution has the symmetry form, right? So regardless of the position, the absolute value will be used for the t-test. To secure that the results are the same, I'm going to choose the second one as the first group. Okay. And then the second variable group here. Okay. And then the labels. I'm going to check the labels. Okay. The first row represents labels, so I'm going to check this box. Then output range. Output range here. See. I'm going to use another sheet. Okay.
Now you can.
T-test 2 seconds. Sorry. Okay. Let's use this occasion. Okay. This one is the result. How about that? How about the mean and the variance? The group 1 and group 2, the mean of group 1, mean of group 2, variance, and then sample variance here, and the observations, number of observations, and the pooled variance, right? Pooled variance, and then degree of freedom, 21, and then t-stat 5.88. You're going to check out that whether this one is the same as the recorded in the Europe, but in the first one here.
I'm going to check out that. Okay, 5.88, right? I'm going to check.
If this value is the same as the values in the material, course material. Where is your course material? This? Where? This
Yes.
one? 5.8.
I want you to keep your course material in this class, okay? So without the course materials, you cannot check out the result, and then the computation result must be the same as the
Values in your course material, right? There is no course material. Can you print this material?
Yes.
For nothing? Free?
No?
No? It takes some cost.
Yes.
I understand. You guys have the notebook. Okay? So you can be here with your notebook, right? Okay, the second one is here. The same calculation will be repeated for the group 2 and group 3. Data. Data analysis. The second group changes to and output range here.
Okay. We're going to check out this. The 6.89 is the same. Okay, here is two types of interpretation, right? This one is the okay. There are two p values here. The first one is one-tailed test, and second one is two-tailed test. I'm going to show you the difference. The T distribution takes the form of the symmetry like this, and then average is always 0, right? Okay, your T value, the falls on here, and then the probability of this is your T value. The same T value is a sum T here, right? This is the P over 2, the half P value, right? This is the half P value. Half P value. The sum of them is a P probability. In this case, your hypothesis mu1 equals to mu2, and your alternative hypothesis mu1 is not the same as mu2. Okay? This alternative gives you the clue. You can regard both values of t. Okay? The fact that mu1 is not the same as mu2 implies that your mu1 minus mu2 may be positive or negative. Okay? So you should consider the both sides, right? But in this case, in our case, for our case, the number of cars 1 to 3 here, and this order implies that the number of trips made also increases. Okay, so here the mean of trip generation is 3.38 and 5.87, 9.43 increases. Okay, the increasing order is accepted. It's assumed to be accepted, right? Increasing order. But in this case, for the case, HA can be like this. mu2 always greater than mu1. Okay? So H0 is the same. Okay? This type of hypothesis testing is called what? One-tailed. Sorry, one-tailed test. This spell is right? Tail. Wait. This one is the two-tailed. Two-tailed test. Okay, the choice of the two-tailed or one-tailed test is dependent on the situation, right? Depends on your convention. Everybody accept that this hypothesis. You can use the one-tailed test, and there is no clue. There is no evidence that the mu2 is greater than mu1. Okay? In this case, this one is right. Two-tailed. How about our example? Our example? According to the number of cars, the number of trips increasing. This is widely accepted by everybody. So in this case, you're going to use you may use the one-tailed test. So our t-test result gives you the two results at the same time. If you use one-tailed test, the t-critical value and the p-value is 5.3 exponent minus to the minus 7, right? But the two-tailed test, the p-value is rather than the one-tailed probability. This is very rational. This is a p-value. Oh, sorry. Here it is. This is two-tailed test, right?